Before we go into histogram, let's quickly talk about grouped data so that you can understand the underlying principle. So why do we group data? When statistical data contains a large number of values, it is difficult to draw meaningful bar charts because it gets too long. So what we do is we group the data in class intervals. So what do I mean by this? Let's take a look at this distribution. This distribution contains the height of 36 students. So we have the height of 36 students listed there. So the first student, his height is 146 centimeter. The second student, his height is 147 centimeter, and the last student, his height is 185 centimeter. So if I wanted to draw this in my normal frequency distribution table, this is what I would have done. I would have just drawn a normal table, and over here I will have my height, and over here I will have the frequency or the number of times it occurs. So for my first height, which is 146, it appears only once here. So my second height, which is 147, it appears only once. So if I continue like that and I go to my height of 165, you can see that 165 occurs 1, 2, 3. It occurs 3 times. Then the height of 166 occurs just once. Height of 167 occurs twice. And I move down to my last height, which is 185, which occurs just once. Now if I draw this table normally, at the end of the day I will end up with 30 rows or 30 different heights, because there are 30 different heights in this distribution. As you can see, this will become so long and too long that trying to draw meaningful conclusions from the table will become pointless. So what we do in this case is we try to group the data. So instead of considering individual heights like we would do normally, then we'll try to group them into groups as shown below. So for instance, rather than look at each of these individual heights, then I can say, why don't I just look at a group of heights? For instance, if I consider height from 145 to 154, so I can now say how many heights fall within that range. So from 145 to 154, I can see that 146 fall in between, this falls, all the way to 153. 155 exceeds this range. So the number of data that fall between that range is 1, 2, 3, 4, 5, 6. So we have 6. So here I move to my next group where I have 155 to 164. And when I do that also, I count the number of data that fall within it, and I see that it is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 heights that fall within this range, and I do that towards I get to the last interval. So this way I can see that instead of having 30 rows as I would normally, I reduce it to just having 5 rows, and this is possible because I was able to group the heights from a particular class interval. So this way it has made my data much more meaningful and easy to read. So now let's talk about the theoretical class boundary. So now if you look at our former class interval that I've shown before, or that we constructed before, you can see that it moves from 145 to 154, 155 to 164. But now what happens for data that fall between 154 to 155? For instance, if I have a data that says 154.5, where in particular do I categorize it? Did I categorize it in this first place or in this second place? Now there is no clear-cut place in which I can classify them because it exceeds this range and it is below this range. So that is where the idea of the theoretical class boundary comes in. So for the theoretical class boundary, to get the theoretical class boundary, what we do is that we subtract 0.5 from the lower class interval. So what these values at the left represent is the lower class interval, while the one at the right represents the upper class interval. So we subtract 0.5 from the lower class interval and we add 0.5 to the upper class interval. So when I do that, when I minus 0.5 from 145, I get 144.5, and when I add 0.5 to 154, I get 154.5. So this interval now represents my class boundary. So this class boundary accommodates numbers that would otherwise not be accountable for. So now if I look at this class boundary carefully, I can see that now for values that are like say 144.3 or 144.6 rather 144.8, I know that they will fall in between this first range. So the idea generally is that when I approximate my class boundary, I should get my lower class boundary, I should get my class interval, and when I approximate it downwards, I should get my interval also. So that is the general idea behind the class boundary. So to recap, we subtract 0.5 from the lower class interval and we add 0.5 to the upper class interval to get our class boundary. So the final concept to discuss is the class width or the width of the class. So the class width is just equals to the upper class boundary, in this case which will be 154.5 minus the lower class boundary which is 144.5, and this gives me what, 10. So you should take note, the class width is not the difference between the class interval, it's the difference between the class boundary. Because if I minus this, I would have gotten an interval of 9. So you should take note to always convert to the class boundary before you subtract to get the class width. So this pretty much sums up the idea of group data. So let's now look at how we apply this when we're talking about histogram.